Hello, everybody. This is Mrs. Carrillo. Welcome to Noble Gas Envy. I was told that the last video was quite boring and that I should mix it up a little bit. So here I am mixing it up a little bit by talking like an old English woman. I hope you enjoy. Okay. Well, we're gonna start with part 1. And I don't think I can do this for very much longer. Sorry. Okay. Yeah, regular me is back. I'm sorry, I couldn't do that. It was starting to turn into cowboy old lady. Alright, so let's just do it in plain English. Get it over with so you can work on your games here. So, in our last lesson we were talking about those valence electrons and remembering how in the periodic table trends, when you go from left to right on the periodic table, your ionization energy, i.e. I'll call that, increases, right? That means it gets harder and harder to take away electrons. And the electronegativity also increases. So we'll electro, and then I'll put like a little negative sign. All right, electronegativity also increases. So that means that these guys, okay, over here, have really strong attraction for electrons. All right, they're super greedy for electrons. So they want electrons, and they ain't giving theirs away. Okay, so they're holding onto their electrons super tightly, and they want other people's electrons. Which also means over here, on the right-hand side, okay, those metal atoms, right, are, not very greedy for electrons, and they're willing to just give up their electrons because they don't have a really good hold on them. The ionization energy is really low on the metal side. All right, so that's kind of where we left off and where, basically the answer to the chem catalyst for today was. So nonmetals are going to have high ionization energies, and they're going to gain valence electrons because they're greedy. And metal atoms have very low electronegativity, and they're going to give away their valence electrons. So knowing that, what we're going to do then is kind of analyze and see how many electrons they're either going to give away or how many electrons they're going to gain. Now, this lesson is called Noble Gas Envy because if you're envy of somebody, you're jealous of them, right? And so we can think about all of the other elements on the periodic table being very envious of these noble gases, all right? And remember, noble gases are in group 8A. So all the noble gases have what we call a stable or full valence shell of electrons. So all of the other atoms or elements on the periodic table want to get as many electrons as the nearest noble gas to them. All right, and when I say nearest noble gas, we can either talk about the noble gas that's, say for example, if we're talking about something in 5A, all right, the nearest noble gas to somebody in 5A would be, looking this way. All right, so forward on the row. So if we're talking about this one, right, the nearest noble gas, all right, is this guy right here. However, if we're talking about a nonmetal on the left-hand side of the periodic table, the nearest noble gas is actually backwards. All right, so if you think about it, okay, it's kind of basically over here. So if you think about the periodic table not being flat, but being round, okay, like, the Earth is round, group 1A is right next to group 8A. Similarly, that we can see on the periodic table that group 7A is next to 8A. All right, so even though it seems like group 1A is on the other side, it's actually kind of right next door. If we think about it as, 3D kind of globe. Okay, so if we take a look at the actual, instructions here, we're going to work through and see how it works for a few. All right, so everybody should have the handout that looks very similar to the very top of this
page here. And so the first thing it says, write the symbol for each element in the appropriate box. So the symbol means, the one or two letters that represent it. So for example, hydrogen is H, right? And helium is He, lithium is Li. Next one is beryllium, which is Be, and so on and so forth. So you guys can figure that out, no problem. Number 2, you're going to use your knowledge about electron organization to make a drawing of the electron shells and the electron placement for elements number 3 through 10 only. That's why those boxes are bigger in size than all the other boxes on your handout. All right, so see lithium, for example. So this is exactly what you guys were doing last lesson. Okay, we were making pictures, right, of the nucleus in the middle. Okay, and then remember this is group 2, so everybody in group 2 is going to have 2 shells or energy levels. Okay, so you can start by doing this. Okay, everybody's got 2 energy levels. All right, and then you're going to put the electrons around it. Okay, so for lithium, he's got 3 electrons, so the first 2 go in the first shell, and he's got, the third one on the outer ring. Remember that your A numbers will tell you the number of valence electrons. So when we do beryllium, beryllium has 4. He's number 4 on our periodic table. It means he has 4 protons, which means he also has 4 electrons. So the first 2 electrons go in the first shell, and then the other 2 electrons go in the outer shell. All right, and so he has 2 valence electrons, 1, 2, okay, because he's in group 2A. If we do the same thing for the next one, boron, which is number 5, all right, so let's put a B for boron. Boron is number 5. He has 5 electrons. 2 of them, the first 2 go in the first shell, and then the other 3 are valence electrons, again, matching up with the 3A, and so you're going to put it right there. So, again, this is exactly what we did all last lesson. So that's what you guys are going to do for instruction number 2. Now, number 3 and number 4 are a little bit kind of trickier in a sense. They're not that tricky, but let's take a look at 3 and 4. So it says in the columns headed by lithium, beryllium, and boron. All right, so that's this column, and this column. All right, you're going to indicate how many more electrons are found in atoms of those elements than in atoms of the nearest noble gas. All right, so remember, the nearest noble gas to them is not neon over here, okay? It's actually helium. Because remember, if we think about it, you can even, pick up your periodic table and twist it into a, cylinder. So lithium is really close to helium. All right, beryllium is close to helium, and boron is closer to helium than they are to neon. And you could even count the boxes. So we could even do lithium is only 1 box away from helium, but he's 1, 2, 3, 4, 5, 6, 7 boxes away from neon. All right, so obviously he's closer to helium than he is to neon. All right, same with boron. Boron is 1, 2, 3 boxes away from helium, going backwards, but he's 1, 2, 3, 4, 5 boxes away if we went forwards. So whatever makes the lowest basically jumps towards the nearest noble gas, that's who you're going to go towards. All right, so lithium is 1 jump away. So what we're going to do is we're going to place a 1 here, okay, just in the bottom of the box. Beryllium is 2 jumps away, right? 1, 2 back to helium, so we're going to put a 2 in that box. Boron is 3 boxes away, so we'll put a 3 in that box. All right, and then what it says is place a sign in front of these numbers to indicate that these elements contain more electrons than their nearest noble gas to them. So helium has 2 electrons. Lithium has 1 more, so he's a +1. Again, helium has 2 electrons. Beryllium has 4, so he's a +2. Boron has 5 electrons. That's 3 more than helium, so he's a +3. Okay? All right, now let's take a look at number 4. It says in the columns headed by nitrogen, oxygen, and fluorine. Okay, so that's these guys. Okay, group 5, 6, and 7. You're going to indicate how many fewer electrons are found in atoms of these elements than in the atom of the nearest noble gas. And remember, the nearest noble gas for these guys is forward on the periodic table. Okay, so for fluorine, he is just 1 jump away from being like neon. Okay, oxygen is just 2 boxes or jumps away, and nitrogen is 3. Okay, which makes sense because if we looked backwards, nitrogen would be 1, 2, 3, 4, 5 jumps away. So he's technically closer to neon than he is back to helium. Okay, so here we're going to indicate how many boxes or how many jumps we are away from the nearest noble gas. So nitrogen is 1, 2, 3. So we're going to put a 3 here. Oxygen is 1, 2. Put a 2 here. And fluorine is just 1. And we'll put a 1 here. And we're going to place a minus sign because that indicates how many electrons he has to gain. Okay? So another way to think about this, guys, is that the metal atoms, okay, groups 1, 2, and 3, have very low ionization energy. They have low electronegativity. So they're going to give away their valence electrons to be like the nearest noble gas to them, which is helium. Okay? And they become like it, like basically kind of they dress up like it, but they're not actually turning into helium. That's huge. A lot of people think we're making these into different elements. We're not. What's happening is that their electrons, okay, the electron count is being like the noble gas. That's why it's called noble gas envy. So the metal atoms, okay, metal atoms always lose. Metal atoms always lose electrons. Okay? On the other hand, on the other side, groups 5, 6, and 7, these are nonmetals. And to get or be like or dress up like their nearest noble gas, okay, which is forward on the periodic table towards them, they need to get electrons. Nitrogen needs to get 3 more electrons to be like neon, right? Oxygen needs to get 2 more electrons to be like neon. So if they gain electrons, you're going to get more negative charge. So that's why we have a minus sign. So nitrogen is going to have a -3 charge. Oxygen is going to have a -2. And fluorine is going to have a -1 because that's how many electrons they need to gain in order to dress up like the nearest noble gas to them. So nonmetals always gain electrons. And so if you remember that metals always lose their valence electrons and nonmetals always gain electrons, then you can just, count up how many boxes or jumps to the nearest noble gas and you'll have their charge. Okay? So that's what 3 and 4 is kind of alluding to. Now, once you've gotten through, you finished up 1, 2, and, we basically did 3 and 4 together. You guys can answer the rest of the questions pretty much by yourselves. I'm thinking it's the rest of the questions are pretty easy. As long as you have an idea, again, that metal atoms always lose their valence electrons, all right, to be like the noble gas nearest to them. All right, so basically, remember the noble gases have 8 valence electrons, okay, except helium, he's got 2. All right, so either way, whether you're going to gain electrons like nonmetals or you're going to lose electrons like metals, you always want to be like the noble gas nearest you. all right, dressed up. It just was Halloween, so think about them dressing up like the noble gas nearest them. They either have to lose electrons to dress up like them, or they have to gain electrons to dress up like them. All right, so hopefully that was a good start for you guys, and it makes sense to you. And, if not, hopefully, work with each other, help each other out, and I'll be back on Friday to answer any questions that you might have. All right, we'll see you then.